Hi, partner.
Oh, hi partner, how are you?
I'm fine. Can I ask questions?
What is it?
What is the objective of our MIR?
The objective of our MIR is to inspire students to love and like mathematics as they realize and see the beautiful application in real-life situations in trigonometry.
Ooh, that's great. How about trigonometric identities?
Just wait and see. Let's first watch a short video.
That's not the end of it. It is just a trailer.
Now let's give some problems about real-life situations in trigonometric identities. Let's hear from Calvin, Riza, Rizali, Kyle, and yours truly on how to solve and explain the importance of our assigned topic.
Outcome. The students are able to simplify trigonometric expression using fundamental trigonometric identities. The students are able to solve situational problem involving trigonometric identities. Hello, today we'll talk all about real-life application of trigonometric identities. But let us define trigonometry first. Trigonometry is a branch of mathematics that studies relationship involving lengths and angles. Application in architecture. Calculating heights of trees. Buildings and mountains. Measuring roof angle, light angle, and distance between objects. Application in oceanography. Measuring the tidal change using trigonometric graph. Measuring the depth of underwater objects. Application in astronomy. Determining the distance in space. Distance between planets and moon phase. Application in music theory. Calculating sound waves. Application in engineering. Calculating alternating electric current. Determining the size and angle of mechanical part using trigonometric relationship. Application in physics. Calculating equilibrium. Calculating force. Calculating work. Application in gaming. Projectile and trajectory in gaming.
Trigonometry is the study of triangles. More specifically, the study of the angles and dimensions of triangles. Although this might sound simple, trigonometry is a vital part of modern engineering, design, architecture, and other fields.
Trigonometric skills plays an important role in a wide variety of careers, including architectures and engineering.
Trigonometric identities, on the other hand, are equalities that involve trigonometric functions and are true for every value of the occurring variables for which both sides of the equality are defined. Geometrically, these are the identities involving certain functions of one or more angles. They are distinct from triangle identities, which are identities potentially involving angles but also involving side lengths or other length of a triangle. In this report, we will solve situational problems involving trigonometric identities.
So let's move on to the statement of the problem. So the problem is the force F in pounds on the back of a person when he or she bends over an acute angle in degrees is given by the formula F equals 0.2 W sine theta plus 90 over sine 12, where W is the weight in pounds of the person. So the first question is, simplify the formula for F. Next, find the force from the back of a person whose weight is 50 pounds if he bends an angle of 30 degrees. Third, how many pounds should a person weigh for his back to endure a force of 400 pounds if he bends 40 degrees? So as you can see that there's a formula already, and if there's a given formula, solving the problem will be quite easier. So for letter A, to simplify the given formula, we will use the sine sum identity, which is sine A plus B equals sine A cosine B plus cosine A sine B. So the formula that was given is F equals 0.2 W sine theta plus 90 over sine 12. Here, A will be theta and B will be 90. So using the sine sum identity, we can simplify the given formula. So copy first 0.2 W and then we simplify sine theta plus 90. So it will become sine theta cosine 90 plus cosine theta sine 90 over sine over 12 is equal to 0.2 W 0 times sine theta. So it became 0 times sine theta since cosine 90 is equal to 0 plus cosine theta times 1. So it became like that because sine 90 is equal to 1 over sine 12. So next, so any number multiplied by 0 is 0 and cosine theta times 1 is cosine theta. So this will be equal to 0.2 W 0 plus cosine theta over sine 12. So next, so any number added to 0 is itself, or the identity property of addition. So our simplified formula will be F equals 0.2 W cosine theta over sine 12. So let's move on to letter B. So find the force on the back of a person whose weight is 50 pounds if he bends an angle of 30 degrees. So the given are the weight, which is 50 pounds, and the angle is 30 degrees. And we're looking for the force. So we will use a simplified formula that we got in letter A, which is F equals 0.2 W cosine theta over sine 12, which will be equal to 0.2 W times 50 times cosine 30 over sine 12. Since W is 50 and cosine theta is 30 degrees. So 0.2 times 50 times cosine 30 is equal to 8.66025404 over sine 12, which is equal to 0.27912. And their quotient will be 41.65. So therefore, 41.65 pounds is the force on the back of a person whose weight is 50 pounds if he bends an angle of 30 degrees. So let's proceed to letter C. How many pounds should a person weigh for his back to endure a force of 400 pounds if he bends 40 degrees? So the given is the force, which is 400, and the theta is 40 degrees. And we're looking for the weight. The formula is F equals 0.2 W cosine theta over sine 12, That is the simplified formula that we got in letter A. So, 400 is equal to 0.2W is unknown, and cosine theta is 40 degrees over sine 12. So, we'll multiply sine 12 to 400, so it will become 400 times sine 12 is equal to 0.2W cosine 40. We could divide this by 0.2 cosine 40. Why? So that we can cancel them, and the only one that will be left is W. So, divide both sides by 0.2 cosine 40. Apply cancellation. So, 400 times sine 12 divided by 0.2 times cosine 40 is equal to 542.82. So, 542.82 pounds should be the weight of a person for his back to endure a force of 400 pounds if he bends 40 degrees.
Identities.
So let's move on to the additional problem. The additional problem is the range R of a projectile fired at an acute angle with a horizontal and with an initial velocity v meters per second is given by R equals v squared over g sine 2 theta, where g is the acceleration due to gravity, which is 9.81 meter per second squared, near the Earth's surface. If Mia, an archer, targets an object 90 meters away from her position, and then she positions her arrow at an angle of 32 degrees and releases the arrow at the speed of 30 meters per second, will she hit her target? So let's find out. So the given is the range, which is 90 meters. We're going to compare it with our answer. If our answer reaches 90, it means that it would reach the target. But if it's greater than or less than 90, it will not reach the target. So based on the given, the angle is 32 degrees and the velocity is 30 meters per second. And lastly, the gravity is equal to 9.81 meters per second squared. So the given formula is R equals v squared over g sine 2 theta, which is equal to, so v squared is 30 squared over 9.81 meter per second squared times sine 2 theta, which is 32. So 30 squared is equal to 900, then multiplied by sine 64, since sine 2 theta times 32 is sine 64, which is equal to 808.91464166.925. Then, we'll divide it by 9.81, which will be equal to 82.46. So, since the answer that we got is 82.46 meters, and the given distance is 90 meters, therefore, she will not reach the target. So, that's all our problems solving situational problems using trigonometric identities.
Generalization. In this report, we are able to simplify trigonometric expression using fundamental trigonometric identities, and we are able to solve situational problems involving trigonometric identities. Learning trigonometry surely makes us adept at solving tricky situations. It provides a strong basis for resolving everyday issues and is undoubtedly helping in handling situations with a positive approach. Of course, it may not have direct application in solving practical issues, but it is used in various fields and have enormous number of uses in our daily life.
That's right. Now that we have seen the importance of trigonometry, let's not forget what we have learned today.
So that's the end of our Mathematical Investigatory Report. Again, we are the Group 4. Thanks for watching!